our final example for sample means and population proportions. So a cereal company is advertising 16-ounce boxes. We take a sample of 50 boxes and find the sample mean weight is 15.5 ounces with a sample standard deviation of 0.9 ounces. We want to test the claim that the true mean of cereal boxes differs from 16 ounces. So we're not claiming that it's definitely larger or definitely smaller. We just want to know, is it different from 16 ounces? So our null hypothesis is what the company is advertising, what we think is true, that the mean of the boxes is 16 ounces. We want to test if it's different from 16 ounces. So we want to test if it can be larger than 16 or smaller than 16. So we're going to just test that it is not equal to 16. We want to do a two-tailed test here to see if it's possible that it is either larger or smaller. So if we just want to test a claim that the true mean is different, we're going to use that not equal to sign, and it becomes a two-tailed test. So let's get our t-statistic that we need, our test statistic, our t-score. We're going to take the sample mean. So the sample mean had 15.7 minus what we think is true of the population. So we're going to use our null hypothesis there, divided by the sample standard deviation over the square root of the sample size. 15.7 minus 16 divided by 0.9 divided by the square root of 50. So we get a negative test statistic, a negative t-score of negative 2.3570. Now, when we get a two-tailed test, we need to go grab either the left or right tail and multiply it by 2 in order to get our p-value. When we need to decide, do you want the left or right tail, we're going to look at the sign of the test statistic. I have a negative t-score here, which means I'm going to go grab the left tail and multiply that by 2 in order to get my p-value. If that had ended up being a positive t-score, I would have grabbed the right tail instead and doubled that. So if it's a positive test statistic, we get the right tail times 2 to get our p-value. If it's a negative test statistic like we have here, we're going to go grab the left tail and divide and multiply that by 2. Okay, so I'm going to jot down my test statistic, negative 2.3570, and my sample size, which I see up here as 50. And now let's go change it up. So I'm going to change up my t-score so I don't forget what it is. Negative 2.3570. I need to change up my formula in here. Negative 2.357, comma, the degrees of freedom is the sample size minus 1. In this problem, the sample was 50, minus 1 is 49, comma, always true. And as I said, since I have a negative test statistic, I'm going to grab the left tail, 0.011. And I'm going to multiply the left tail times 2 in order to get my actual p-value that we need to use. So I'm actually going to use a p-value of 0.022. And we are testing this at the claim of alpha of 0.05. So is your p-value bigger or smaller than the alpha we're testing? In this case, the p-value is smaller than our alpha, which means we have statistically significant enough evidence to reject the null hypothesis in favor of the alternate hypothesis. Weirdly enough, I think most of my problems came out this way. If your p-value is smaller than your alpha, we reject. If your p-value is larger than your alpha, we fail to reject.